Hello everyone, today in this video we'll be discussing the module 5 of TOC super important questions, and there are two most repeated topics, which is the theory questions. Okay, it's very easy to learn these theory questions and they get asked in mostly both of the hours. Okay, most of the times it gets asked in both of the hours. And designing Turing machine. Okay, so there is not like a single hour will be asked something specific question, because there are only two topics are there. So some theory questions I've selected from the previous paper which has been repeated more number of times, and designing Turing machine the most repeated questions from the previous schemes, also from the 18 scheme, 21 scheme, and 22 scheme previous paper model paper. I've analyzed all of them and selected the questions which are most repeated. So if you study these two, there's a high chance you can score full marks in this module. Okay, so before starting, please do like and subscribe. It helps me make more videos like this. And if you want the PDF of it, or if you have got any doubt, you can DM me on Instagram here. Okay, let's get started. The first theory question is: write a short note on recursively enumerable language and also multi-step Turing machine. Okay, so recursively enumerable language means the set of languages which can accept in the Turing machine is called recursively enumerable language. Means if this is the Turing machine, which all languages are accepted by Turing machine, those are recursively enumerable language. Okay, or regular expression languages. The term recursively enumerable comes from the computational formalisms predate the Turing machine but define the same class of languages for arithmetic function. Okay, this much only you have to write. A language is recursively enumerable if L is equal to L of M for some Turing machine M. Okay, and if the string W is given to that Turing machine, the machine halts and outputs yes if it belongs to the language. If it does not belong to the language, TM halts and outputs no or runs forever. Okay, so long range goal is to prove undecidable languages consisting of pair MW. M is a TM with the input alphabet 0 and 1. W is a strings of zeros and ones, and M accepts the input W. Okay, so the languages which are accepted by TM is called as recursively enumerable language, and there are a few rules to it. Okay, sorry, not rules, the goals to it. Okay, and multi-tape Turing machine is also a Turing machine but with multiple tapes. Okay, or more number of tapes. Okay, device has a finite control state. This is called as finite control state, which is going to mark the values in each of the tapes. Okay, this is called as a tape, and this is the finite control state. Okay, and each tape is divided into cells. Each of this is called a cell: cell 1, cell 2, cell 3, and cell can hold any symbol of the finite tape alphabet. Each cell will have one alphabet. Okay, and the states include initial state and some accepting states. These states can be either initial state or accepting states. Okay, so that will be the multi-tape Turing machine. Initially, all the inputs will be of finite sequence input symbols. All the other cells of the tape holds a blank, but when and as and when we move forward, the blank will be replaced with the alphabets. Okay, and the head of the first tape is at the left end of the input. Head will start from here and it will reach to the right end. Okay, next is explain halting problem. Okay, so there are two cases possible in Turing machine. For an input string with some configuration, machine will halt after finite number of states. Another cases, it will never halt. Okay, means it will keep on running in an infinite loop. Okay, so this is the halting problem. We don't know which one will be halted and which one will not be halted. Okay, so the halting problem is unsolvable. This much thing you have to write for halting problem. Okay, next is write a short note on non-deterministic Turing machine. Non-deterministic is a theoretical model of computation that extends the deterministic Turing machine by allowing multiple possible moves for a given state. In the normal Turing machine, for one state, you will be moving to one place and one input symbol, but here you will be having multiple possible moves. Unlike the deterministic Turing machine, where exactly one action is defined, NDTM will have many actions defined. Okay, it is a 7-tuple Q, sigma, and this is some symbol, and tau, q naught, b, and f. Okay, so each of these symbols you have to write, and where the transition function is defined as follows, meaning the transition function will return a set of possible moves, not just one move but many moves it will return. Okay, so many moves it will return. Next, if an input string is accepted by NDTM, at least one computational path leads to accepting state. If all possible paths reject or do not halt, the string is rejected. Okay, see, the criteria is at least one path should be accepted. Okay, next is in terms of computational power, non-deterministic and deterministic Turing machines are equivalent. Okay, both have the same computational power. Every language accepted by NDTM also be deterministic, though possibility with greater time complexity. Okay, non-deterministic will be doing it in a lesser complexity, and it does not increase the class of languages that can be recognized by Turing machines. Okay, next is briefly explain the techniques for Turing machine construction. Also write the applications of Turing machine. How do you construct the Turing machine? Okay, first one is the storage in the state. In the state, you will be having some limited information that can be directly stored in the finite control state. This technique is useful for remembering small amount of data such as flags or symbols. In the finite control, you will be having finite control. You will be having some data which is lesser data, but that will be very useful data. Okay, and you can have multiple tracks on the tape. Okay, the tape is conceptually divided into multiple tracks. allowing more than one symbol to be stored in a single tape cell. Okay, it helps in keeping additional information without increasing the number of tapes. Subroutine or modular design. Complex Turing machines are constructed using smaller machines as subroutines. Each subroutine performs a specific task and returns the control to the main machine. It is like programming, wherein you will be having a main function, and inside the main function you will be calling some small functions. You will be doing some computation and returning some value. That is called subroutine. In the terms of Turing machine, that will be called as subroutine or modular design. Checking off symbols on the tapes are marked or replaced once processed. Once it's processed, you'll be checking off means it is done. Like that, you'll be writing. Multi-tape machines, instead of one tape, multiple tapes are used to simplify the design and improve efficiency. At the same time, you will be doing multiple operations like that. Okay. And non-deterministic choices. Non-deterministic allows the machines to explore multiple computation paths simultaneously, making certain constructions easier conceptually. Okay. And what are the applications of Turing machine? Language recognition. It recognizes which are recursively enumerable languages, and functional computation. They can compute any computable functions such as arithmetic operations. And modeling algorithms, it is used to define theoretical model for describing and analyzing algorithms. You can analyze the algorithms and you can decide what is to be done, whether a problem is decidable or undecidable. It is used to determine that. Okay. And foundation of computability theory. Turing machines form the basis for studying limits of computation and complexity theory. Using a computer, what all you can solve, that limitations is given. That limitations we can find out using the Turing machines. Okay, so those are the applications of Turing machines. Define Turing machine. Explain the working of Turing machine. So, what is a Turing machine? A Turing machine M is a seven tuple, namely Q, sigma, and this slide I don't know what it is. Delta, Q naught, B, and F. Okay. Now see Q. Okay, Q is the finite set of states, all the states. Okay, Q naught, Q1, Q2, all the set comes here. Okay, and this symbol, a finite non-empty set of tape. Okay, tape it is. Tape also I'll discuss what it is. B is blank symbol. Okay, sigma is non-empty set of input symbol. What are the inputs can come? A, B, C, D, and all. Delta is a transition function. Q naught is the initial state. F is the final state. Okay, these things you have to just write the definition for Turing machine. After that, working of Turing machine. The Turing machine can be thought of as a finite controlled connected read-write head. Okay, there will be a read-write head which will be connected and it will be moving. It has one tape which is divided into many cells. There are many cells divided and it is a single tape. Okay, so the block diagram of the basic model is given below. Okay, so here you have to make it like this: a tape here, and here we will be writing the symbols A1, A2, A3, and followed by a blanks here B, 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 and so on. Read write head is here and finite control is here. Okay, each cell can store only one symbol. Okay, each cell can have only one symbol. The input and the output to the finite state is offered affected by RW head. This RW head, the input will be written by this and the output will also be taken by this only at one cell at a time. It simultaneously can determine four things: new symbol to be written, motion of the tape, whether it is left or right. So this tape can move either left or right. Okay, based on the scenario. Next state means in which next state it will go, and whether to halt or not means whether it has reached the end, whether it should stop moving or not. Okay, these four things will be determined: new symbol to be written, motion of the tape, next state, and halt or not, simultaneously by the RW head. Okay, this is how the Turing machine works, which is demonstrate the model of linear bounded automata. So LBA we have to explain, and here what is the main key points is you have to just remember, just make a diagram like this, and the ending will be like a tape here, and the ending will be dollar here, starting and ending state. Here it is constrained. Okay, the length is constrained here, it is not unlimited as in the Turing machine. Here it is constrained. Final state control is there, and this is the read write head, and moving right our head is moving to the right only. Okay, like that. It will always move to the right, next, it will never move to the left. That is difference between TM and LBM. Okay, read write head, they will be having RN cells. The answers will be written here. Okay, means what are the values taken into input and from the given by input and taken from the output, that will be written here. And linear bounded automata is nothing but TM plus input constraint. There will be a constraint input, and in between that it will operate, and only it will move right. Okay, and this is a sample string here, A B B B A, and here all the rules of TM will be applied here. So few key points: is defined by 7 tuples, it has 2 tapes, it is more powerful than PDA, and it can accept A power n, B power n, C power n. It is less powerful than TM. Okay, more powerful than this but less powerful than TM. It does not come under non-deterministic or deterministic. It does not come under non-deterministic or deterministic. Okay, it is a separate concept. It is designed for context sensitive languages. Main key point. Okay, so this is the 7 tuples which is used to define. two extra symbols are there. This one, opening and closing one, are used as left hand and right hand marker, or you can use dollars also. Okay, and input lies between these markers, as shown in this diagram. The input lies between these markers. Okay, so this is one question which is LBA. This is there in the 2024 model paper of BCS 503 2022 scheme. Okay, so don't miss this question. L is equal to a power n and b power n. Now we have to solve it using Turing machine. Okay, so let me give you a brief overview of what is Turing machine. So a power n, b power n, and n is greater than or equal to 1. What are the strings that can be formed? Strings that can be formed, the least string is, if a n is equal to 1, it will be ab. If n is equal to 2, it will be a b b. If n is 3, it will be a b b b, right? And it will keep on going. Now, these are the strings, and we have to design a Turing machine for that. So I'll be taking a bigger string here, okay? Because smaller string will be easier, and not all the factors will be covered. So let's take AAA. So Turing machine, what it does, in Turing machine, it's a tape. Okay, a tape will be there, and in that tape the input string will be there, AAA BB, followed by a blank symbol here. Capital B is a blank symbol. Okay, and those will be partitioned by spaces here. Okay, and we'll be starting from here. Now see, this is movable, this can move here and so on. Now, to accept this string, what is the rule I need to define is, whenever I have an a here, whenever I encounter a, that a I will be replacing it with x. Okay, I'll be replacing it with x, and I'll be finding a corresponding b for that. Okay, since I have found a here, I'll be finding a b now. The b came here. When I move forward, I found a b here. Now, for this b, I have to replace it with some another letter. Now, I found a b for a corresponding a, then again I'll go back and see if there are any more a's or not. So I found here another a. What I'll do, I'll just simply rub this, make it as x, and I'll move forward, find a corresponding b here, that I'll make it as y, and then I will come back again. This a is here, I'll make it as x, and here a b is there, I'll make it as y. After that, I'll go back, I'll find there is no more a's, I'll come back and see there is a capital B, which means that after equal number of a's and b's are over, according to this question, a power n, b power n, I reached a b. That means it's a valid string and it's accepted. Okay, suppose that instead of this b, there was another b here, and here was a b. When I was coming here, I found another b here, but this b does not correspond to any a here, right? In that case, this will not be accepted. Okay, so this is what a Turing machine does. We'll be solving this question using string AAA BBB. Okay, now let's take this string here. I'll take it in the same way I took before, AAA B B B and one capital B. Okay, this one I'll be making it in a box. Now we'll be starting from here. Okay, starting. Now, first I have encountered an A. Okay, so Turing machine, I'll be making it like this. I have to make a DFA here. First state I'll always make Q naught here. Okay, now in Q naught, first I encountered A here, right? Because always it is A power n, B power n, always I'll encounter A first. So whenever I encounter A, I have to move to another state. Okay, whenever you encounter A first, whatever the letter is there first, you have to move to another state. What I encountered, A. What I'll be replacing it with, X. Where I'll be moving, right. Okay, like this you have to do. What I got, what I'll be replacing it with, where I'll be moving. So I got A here, I'll be marking it as X, and I will be moving into the next input here. And this one will be Q1 here. Okay, now I have moved to Q1. Now in Q1 also I have to do the following. Now here if I find A, after this one I replaced A, now my target is B. I have to find B, but this is not B here. So what I have to do? I have to keep it as A only and move to the next one. I will not do anything. Again I'll move to the next. So what I just did is I found an A here. Okay, what I wrote on top of it, I wrote another A, means kept it as same, and I moved to the right. Now again I found this one A. I have to write A on it again and move to the right. Okay, so here again the same thing happened, therefore a self loop can exist here. Okay, now I found B here. Whenever I find B, what I have to do, I told you I'll replace it with Y. Okay, so now I replace it with Y, and this arrow I'll be moving back to find more A's. Okay, but directly I'll not find A. I'll be telling you how we need to find, because this A we need to consider, not this A, right? So let's have a look how we are going to proceed with this. Now after I find Y here, I move to the left. Okay, so there was a B, I replaced it with Y and moved to the left. Okay, Now after moving to the left, I came to Q2. Now in Q2, I found another A here, but this is not the A which I have to consider. I have to go back here, right? So what I just did, I kept A as such and moved to the left. That is A comma A comma left, and that can be a self loop. No matter how many A's are there, I have to all skip it until I reach X. So that after that X, I have to move to the right. Now once I reach X, then I will be have to move to the next one, because this is the A that needs to be considered. Once I reach X, I'll be getting to know that the next A is the one which I have to consider. Okay, so in that case, the X transition will also remain the same. Suppose that after this point I kept A as same, I reached here. Now X is my input. If X is my input, I have to move right. So what I will do, I'll come back here. I'll come back here. You'll understand why I came back here. And here what I did, X I encountered. From this state, I encountered X. So I have to keep X as such and move to the next here. So I'll keep X as such and move to the right. Okay, right I moved. Now, in this spot I came, right? This is same spot as the first A, right? This is the first A. From here only I'm starting, and from here again the same thing will repeat. A will replace by X, move to the right, cover all A's, then when you encounter B, make it Y and move to the left. Here I have to again do the same thing, mark it as X, move here, skip all A's and skip all Y's also, another new concept will come here. Then when I get B, replace it with Y, come back again left and find the first A again. So I have to repeat the same thing. So I'll not take another state and write the same things. Instead, I will take to the same state from where this is starting again. Okay. So again, let's trace what will happen. Now I'm in this state. A encountered A. Yes, I encountered A. Mark it as X and move right. Mark it as X and move right. Now here A. I moved right. I moved into this state. AAR. Keep it A only and move to the right. Now I am still in this state only. In Q1, what I encountered. I encountered Y, but Y is not defined. If I encounter Y, simply what I have to do, I have to move to the right, because my target is to find B for the corresponding A here, which I marked X, right? There was an A, I marked X. For that A, I need a B, so I need to skip all A and Y in between. So if Y also comes, I'll be writing Y comma Y, move to the right. So skip this Y, move to the right. If you find B, mark it as Y and move to the left. So mark it as Y, move to the left. In left I moved here, and now I encountered Y here, right? From here I moved to the left. Now I encountered a Y here. Now if Y comes in this spot, have I defined for it? No. What I have to do if Y comes? I have to ignore it, because my target is to find the first A, right? So I'll ignore it, means Y will remain Y and I will move to the left. When I move to the left, I find an A here. So what is defined for A here? Keep it as A and move left, because I'm not sure whether there is another A here or not. We have to check it. If there is another A, we have to consider that one, right? So we need to check if there is A here or not. For that, I'll make AAL. So I'll keep A as A only here and move to the left. And here I encountered X. From this state, I encountered X. X means XXR. X, keep it X as same and move to the right. Now this is confirmed that this is the first A which we need to consider. Now I'm in this state. Again, AXR. I'll make it as X and I'll move to the right. Now Y is present here in this state. YYR, skip. Again Y is present here. YYR, skip. Again B here. Now from this state B means BYL. Make it as Y and move to the left. Now I move to the left. I find it as Y here. From BYL I came here. YYL, move to the left. Again after that move to the left. Now X here, right? In this spot I found X. So what I have to do? XXR means I have to move to the right here. So I move to the right here. XXR, right? XXR. I'll keep X as such and move to the right. Now I move to the right here. Now XXR I went to the Q0 state. Now in Q0 state I encountered a Y. Now what I have to do? Now see, if after an X I found Y, means that all the A's are over and all the B's also over, because A power n, B power n, all the A's and B's are over. Now in this case what I have to do is I have to just skip all the Y's and move to the last state here, right? No matter how many Y's are there, I have to move it and reach here. For that, I'll be taking another state here, y, keep it as y only and move to the right, and I'll reach a state q3. Here also I'll make a self loop here. No matter how many y's are there, keep it as y only and move to the right. So I'll move all the y's here, and I'll move to the right, and I'll reach a capital B. When I reach a capital B, what I'll do, nothing, B, B, keep it as B only, and move to the left or right, whatever it is, it doesn't matter. Okay, so that's it. I'll be moving to the Q4 state, which is the halt state. It is called as halt state. Okay, so this is how you make the diagram, which is the transition diagram for the A power n B power n using Turing machine. Okay. And one more thing is there, after you have done this one, in question if they ask you to do the test for this, any string if they give and ask you to test it your diagram using the string, in that case you have to do the instantaneous description also, id. Okay, let's have a look for one question how do we do the ids. Okay, let's take a. Okay, for that first you have to do it is as follows. For first state is starting state q naught. Okay, now I'm doing it for A, B, 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 and a capital B here. Now, Q naught A. When Q naught on A, what's happening? It becomes X and move to the right, right? So, and we move to the Q1. So here what we do, okay, listen carefully. First of all, Q naught becomes Q1. Okay, so Q naught we have to write it as Q1, and A becomes X. We have to write X instead of A. So first we'll write X here, and right means Q naught became Q1 and moved to right. So we have to mark it in right. Okay, like this it will be. From left it became to the right, and then this 2A B B B. Got my point? Like that only. Okay. Now Q1 on A. If Q1 on A, what you have to do? Just move to the right. So here it will be X A Q1 A B B B capital B. Okay. After that Q1 on A, again same thing. X Q1 B B B B. Now Q1 on B, what happened? Q1 on B, it goes to Q2 and becomes B becomes Y, Q1 becomes Q2, and Q1 goes to left. Now if Q1 goes to left after making B as Y, so let's make B as Y. Q1 goes to left means A will come here and Q1 will be present here. Here it will be A, and this X will be here, and this will be B B B. Okay. Now after that it is I am present in this state. Now it is AAL. Okay, so Q1 on A, Q1 on A, it will remain A and move to the left. So X Q1 A Y B. Okay, so this Q1 I shifted it left. That's all. Okay, and made this A only, like that, like however it is. I let it state as such. Okay, now again Q1 A, again same thing. Q1 A, I have to move to the left, so I'll move Q1 to the left. X A Y B B B. Okay, now Q1 on X, Q1 on X. Okay, so Q1 on X, what should happen? Sorry, not Q1. This is Q2, right? I forgot to change here. Yeah, this one. After Q1 B it's encountered, Q1 B it's encountered, it makes Q2, right? So Q1 B I have to mark it as Q2 here. This is also Q2, and this is also Q2. Now Q2 on X, Q2 on X, it will become Q3. I mean Q naught, and it will go to the right. Okay, so X is here. It will become Q naught, and it will go to the right. That means X will become left, and a Q naught will come before A. There will be second A here, B B B. Okay. Now Q naught on A. What is Q naught on A? It will become X and move to Q1. Okay. So again X, it will become X and it will move to the right. Q1 A Y B B B. Okay. Now Q1 on A, make it as keep it as such and move to the right. X X A Q1 Q1 on Y, Q1 on Y also it remains same. Move to the right. Okay. Let me insert some space here. Okay, now see here. Now what we are supposed to do? Where we are presented. Okay, Q1 on Y. What is Q1 on Y? Q1 on Y is it will remain Y and move to the right. So now here it will be X X A. Q1 will move to the right, remain Q1 B B B. Now Q1 on B. What was Q1 on B? Q1 on B, it should become Q2. It should make it B as Y and move to the left. Now see, it made it as Y. Okay, let's write it here. It made it as Y, and Q1 move to the left means this Y will come here and Q1 will be here, A will be here. Okay, like this it will be, and B B, and Q1 became Q2. Okay, now Q2 on Y. What is Q2 on Y? Q2 on Y, it will become Y only and move to the left. It will remain Y and move to the left. Now Q2 on Y, it will remain Y, Q2 only and move to the left. So it will be X X Q2 A Y Y B B. Okay, now Q2 on A. What is Q2 on A? It will remain A only and move to the left. Now X Q2 X A Y Y B B. Now Q2 on X, it will become Q0, move to the right. Right? Q0 A Y Y B A. Q0 on A is Q1 and it will make the A as a B B. Now what is Q1 on Y? Q1 on Y, it should remain Q1 only and move to the left. I mean right. Q1 Y B B. Now Q1 on Y, it will remain Q1 only and move to the left. I mean right. Then X X X Y Y. Now Q1 on B, it will become Q2. This will become Y, and Q1 will come left. Right. So Q1 will become Q2 and come to the left. It will become Q2, come to the left of this one, and this will also become Y B B. Now Q2 on Y, Q2 only and move to the left. So it will be X X X Q2. This will become Q2 only it will remain, and Y B. So that's what Q2 on Y was, Q2 only, right? Q2 on Y was Q2 only. Now after that, again it encountered the same thing. Let me insert some space. Okay, now Q2 on Y, it will remain same. X X Q2 X Y Y Y B. Now Q2 on X, it will go to Q0 and move to the right. Now Q0 on Y. What is Q0 on Y? Q0 on Y, it should remain Y and move to the right. Q3, it will become Q3 and move to the right. X X X, move to the right. This becomes Q3 Y Y B. Okay. Now Q3 on Y, what it is? It should remain same and move to the right. Q3 Y B. Now again it remains same. X X X Y Y Y Q3 B. When Q3 on blank space it encounters, what should happen? Q3 on blank space it encounters, move left or right, whatever it is, and halt. Or just keep it as okay. It doesn't matter, but still just keep it on right. So keep it as B only. X X X Y Y Y and B Q3. That's all. Design a TM for the language. This language is given showing that the string 112233 is accepted by the ID, instantaneous descriptor. Okay. First you have to make the Turing machine. How we will make the Turing machine? In Turing machine, first you have to make a state here Q0. Okay. Now in the Q0, first my string. Okay, my string is what 112233. Okay, this is a string which is given to us. So we'll take this same string into consideration and we'll proceed. Okay. Now see, I am at Q0. Okay, and my read write head is present here. Okay. Now what I'm encountering? I'm encountering 1. Whenever I encounter 1, my rule is that I'll make that 1 as X. Okay, I'll make this 1 as X. And what I will do, I'll move to the right. like this you have to write what you encountered, what you will make it as, and where you will go. Right. So right means I'll be going it here. Okay. After that I'll reach q1. Okay. In q1 I found another one here. No matter how many ones I find here, I'll be staying in the same state, and I'll be, if I find one, I'll be keeping it as one only and moving to the right. This is the rule. Okay. Whenever we find the first symbol, after that the same symbols, how many times it's repeated, it will not matter. We have to keep moving forward. And while how many ones are there, suppose that 3 ones were there, it will skip all 3 ones and it will reach here. Whenever I reach 2, whenever I encounter 2, okay, suppose I encounter 2, I'll make 2 as y. Okay, for different symbols we have to use different letters, and I'll move again to the right. Okay, I'll move to the right again. After moving to the right, no matter how many 2s are there, I have to skip all those 2s. So I'll be making another self loop here, which will be 2 comma 2 comma r. Okay, I'll be skipping all the 2s here. Okay, I'll insert some space here, it's becoming too much congested. Okay, and okay, 2 to r is present here, right? So 2 to r I'll make it here. Okay, 2 comma 2 comma r. Now I have moved to the right. Now after that I'll find a number of 2s, and I'll skip all of them. I'll move to the 3, and this 2 I had made it as y, right? I forgot to change this 2. I have made it as y, right? This 2 I have made it as y. Now I'll move to 3. Now when I am in 3, okay, if I encounter 3, I'll make it as z and move to the left. I'll not move to the right. Okay, I'll move to the left. You got the point? I'll move to the left. There is a reason for that. Okay, I'll be explaining why I'm moving to the left. Okay. Okay, I'll be moving to the left from here after marking it as Z. Okay, don't confuse, this is 2. Okay, this is 2, I'll write 2 like this. Now when I move to the left, I'll be encountering n number of 2s. Okay, I'll be moving to this state q3, and in q3 when I move to the left, I'll be encountering n number of 2s here. So all those 2s I have to ignore. Okay, because I'm going back and finding the next one here. Okay, so that's why how many 2s I get, I'll have to ignore. So 2 comma 2 comma move left. After the 2s is over, I'll be finding y's here. For all those y's I have to ignore y comma l. After ignoring the y's, I'll come 1 here. Once also I'll ignore 1 comma l. I need the first one. Okay, so I need to find out which is the first one. Then I'll reach x. Whenever I reach x, that will denote that I have reached the end. Okay, so whenever I reach x means that is the one after which the first one is there. So whenever I reach x, I'll be coming back here, and I'll be writing x comma r. X, I'll keep x as same only and move to the right. So now I'm currently present at the first one. So basically what happened here, the thing is 1 power n, 2 power n, and 3 power n. How many ones are there? That many 2 should be there, that many 3 should be there. And this is a string which is given. So why, by doing this the thing in this way, what's happening for this one, this y is marked, this 2 is marked, and this 3 is marked. So for one set 1, 2, and 3 is marked, another set 1, 2, 3 is marked. That will ensure that the number of 1s, 2s, and 3s are same. That's why we are using in this way. Okay, that's why you got to know after z why we did not go forward, because we need to check which another set is there which can be taken and again move forward. Okay, until this is over, we need to move forward. How many ones are there? That many 2 should be there, that many 3 should be there. That should be confirmed first, then only we'll reach the final state. Okay, so now we are present at 1 and in this state. Now what is the rule? 1 comma xr. So I'll be just making it as x and moving to the right. So when I move to the right, I have y here. Okay, now when I move to the right, I encountered a y, but the definition is not present here. Encountering 1 is there, encountering 2 is there, but encountering y is not present. If I encounter y, just skip it, ignore and skip YYR. Okay, just ignore all the y's, and when I move to the 2, I'll be marking it as y and moving to the right. Okay, I'll mark it as y and move to the right. After I move to the right, I am in this state here. Now in this state, I am in right. I have to ignore n number of z's also, because these z's are over. I have to ignore n number of z's. So z z r. Okay, n number of z's will be ignored, and I'll be moving to the 3. Okay, actually this is 2. Okay, not z. This is 2 I have written. Okay, don't get confused. 2 2 r, and we have defined for z z r also. Okay, so the number of z's will be ignored and 3 will be here. 3 comma z l, again 3 will be here, and 3 will become z, and I'll move to the left. Okay, now after I move to the left, I'll ignore all the number of uh, z's here and y's here and x here. Okay, also this is defined for 2, I'll have defined for z. How many z's are there? All I will ignore until I reach x. After I reach x, I'll move to the right. Okay, see, I'll come here, and I'll reach x while I am considering x, because after x only the next one is there. In case the next one is there, I have to reach x. From there I'll check the next one and move here, like how we did in the previous iteration. So I'll reach till x. After I reach x, I'll keep it as x only and move to the right. When I move to the right, I'm in this state. In this state, if I have 1, I'll again follow the same path. If I don't have 1 and I found as y, that means the number of 1s are over, the number of 2s are also equivalent, and number of 3s are also equivalent. How many 1s were there, that many y's are there, that many z's are z is there. Okay, so if I get y after an x, if I get a y, that means no more 1s are there. I have to stop executing. So after this, if I encounter a y, okay, I'll keep y as same and move to the right. Okay, I'll be moving here. Okay, I'll be moving here, and I'll be making a new state here, q4. And here I'll be ignoring n number of y's after that. Okay, y comma y r. I'll be ignoring n number of y's after that, and after that I'll be encountering z's also. So that also I'll be taking a new state here. Okay, z comma z. If a new symbol comes, take a new state, it is better. Okay, and I'll be ignoring the n number of z's after that, z comma r. And after all the final state here, there will be a blank space. Okay, there will be n number of blank spaces here. Okay, that will be marking the end of the string. After that, if I find a b here, okay, b comma b comma, you can keep it l or r, I'll be reaching the final state, which is q6. Okay, so this is how you define the Turing machine for the given language. Okay, now for this string we have to use it by the id. Okay, this is a 12-mark question, very important one, don't miss any of these things. After you have done this one, okay, you have to also write the transition functions. Okay, one transition function I will write, the rest of the thing you have to write by your own. Okay, now see, q naught is present here. Okay, q naught, when I am present in 1 and I have encountered x. Okay, when I am present in 1 and I have encountered x, what I'll be doing is I'll be moving to the right and going to q1. Okay, so here I'll be writing q1 comma r. Okay, like this, q1, and where I moved to the right. Like that you have to do for all of them. Okay, this is the transition function. Just confirm this syntax as same if it is having some different kind of syntax, but mostly this is the syntax only if I am writing it correctly, but just confirm it in the official notes also. Okay, so this is the transition function you need to write. Okay, like that for all of them you write a transition function. After that, if they ask you about the id specifically, you have to write. Okay, in most cases they'll ask it because it's for the 12 marks. So how do you do it by id? Okay, for the id also I'll start it and show the first few steps, because id instantaneous descriptor, it will take a lot of time. Okay, once you get the point you will be able to do it by yourself. I'll be just showing you how do you start it. Okay, instantaneous descriptor. Okay, okay, now see, instantaneous descriptor, how you will do, just take the same string here. Okay, the same string is 112233, and the starting state you will take q naught. Okay, so write it like this. Okay, this symbol you make, write q naught 112233. After this, what you will do is you'll be writing this same like this only, q1 q naught on 1. Okay, q naught on 1, where it goes, q naught on 1, it goes to q1 and it becomes x. This one became x and went to q1 in the right direction. So what you have to do is q naught, it became it made it as x. Okay, it made this one as x, and q naught became q1 and it moved to the right. Got the point? It became q1, moved to the right and made it as x. Next, q1 on 1. After that, q1 on 1, you have to see this and see what will happen. q1 on 1, keep it as 1 only and move to the right. Okay, keep it as 1 only and move to the right. X, keep it as 1 only and move to the right, and stay in the same state only, 2233. Okay, again, q1 on 2. q1 on 2, where it's going? q1 on 2, it will make it as y and move to the right to q2. Okay, so this will be x1. q1 on 2, it will make it as q2, it will become q2, and first it will make it as y and it will become q2 and move to the right. Okay, very carefully you have to do. If any mistake is there, you might lose the marks. Okay, like that, after that q2 on 2, like that you have to keep on going. If it is left, means the same thing you do it in left direction also. Okay, for the more information of the entire descriptor, you can watch the module 5 video. There I have explained in the first or second question the instantaneous descriptor. The link you can find in the playlist in the description box. Okay, module 5 TOC. Okay, For the same question, like this question only, I think it was 1 power n, 2 power n. For that question, I solved for instantaneous descriptor also. Okay, so these three things you have to write, and you'll be easily able to score 12 marks. Okay, so don't miss this type of this question, very important one. Okay, in this question we have been given that we have to make the transition diagram for odd or even palindrome, so both the cases are possible. So even palindrome we have already discussed, it will be like even palindrome here, the length will be even. And what about the odd palindrome? In the previous case we had a c in between, right? So this was an odd palindrome, a b c b a, but in this case we will not have any extra letter like a c, but we'll be using either a or b only. So it will be like a b b b a, or it can be a b b a b a. Okay, a b a b a. So the middle letter will be either b or a itself. Okay, now so how do we handle this case? So the starting will be same, the ending will be a bit different. So let's have a look. So we'll be making it as the previous one only, will be in q naught. And in q naught, whenever we encounter an a or we encounter a b, there are two possibilities: we encounter an a or we encounter a b. If it is a, we'll make a blank space and move to right, and if it is a b, we'll be making it as a blank space and moving to the right. Same thing now in q1, we'll be ignoring the n number of a's and b's after that, so it is aar and bbr. After that, if we encounter a blank space after that, we have to make b b L, right? If it's encountering a black space, you have to come back. Like the previous two questions, same thing here also. And in Q2, when we come back here, since I had started from A, I have to check back again A here only, right? I have to check again if it is an A or not. So in case if it is an A, what I will do is A comma B comma um, L, right? I'll make the A as B and move to the left. Okay, that is Q3 now. Now the same thing goes for the B also. Now this will be Q4 here, and in Q4 I'll be ignoring n number of A's and B's, so it will be A comma R and B comma B and R here. Okay, and after that, when I encounter a blank space, that is the end of the string, I'll be moving to the left. I'll be coming to Q5. In the Q5, yeah, if I encounter a B again, that means before the blank space there is a B. That means I have to make it as a blank space and move to the left. Okay, now this much part is in this part. If you don't understand like how I did this, the previous two question, any question you can see, this part I've explained using an example as well. Now after this part comes the difference. Okay, now let's consider an example here. It might be like this: a b, a and a b here. Okay, now see, a, I considered it, I made it as b, and I came here, I found this a, I made it as b. Now I went back here. When I was going back, I found a b here. Okay, when I found a b here, I'll make it to the right. So in from this spot, I'll ignore n number of a's and b's first. A comma r, I mean not R, I'll have to move the left, right, so it will be L, B comma L. After ignoring a number of A's and B's from this part, again I encountered a B here. So when I encounter a B, I will be coming back to this point. Okay, that is the same as previous one, B comma R. After R, I encountered this point here. From here, I got a B. Now, in between, it can be either B or A. If it's an odd palindrome, there are two possibilities. Firstly, it can be odd palindrome like this, or it can be just A like this, right? Even palindrome, which will be both B in this case. Okay, both B are there, and I'm in this spot now. I'm in this spot now, and I did BBR, right? So BBR means I'm in this spot now for if it is an odd palindrome. If it's an even palindrome, I'm in this spot now. So this is even. Okay, now if it is an odd, let's consider the first odd. Here in between, I could have had A or B, right? And I'm in this state. Now I could have had A, I could have had B here. So whatever it is, A or B, what I have to do, I have to convert it into a blank space and move forward. So I'll convert this into a blank space here and move forward. When I move forward, I got a B here. When I move forward from here, I am in this state, I got a B. Now B comma L. Now B, keep it as B and move to the left. Now I came here. Okay, now I'm in this spot and I'm in this state. Now I have encountered a B. Is B defined here, capital B? Capital B is not defined here. If I get a B before a B, that means the string has ended, right? And from the, if the string has ended, that means that from here I have to just write B comma R. Again move to the front. If B is encountered before it, that means string has ended. Same thing goes from here also. It will be again B comma R. If I have encountered A in between, so I'll choose this path rather than this path, and I'll again come back to the same position here. And this is the halt position, which is Q6. Okay, so this is the halt position here. right? So this was about the odd palindrome in this case. If it's an even palindrome, what will happen? Even palindrome means I was in this spot here, right? I am in this spot here. Now after this I encountered a B again. After this I have encountered a B, right? If I encounter a B after this one, what I am supposed to do? Is B defined here, capital B from Q naught? Is it defined? No, it's not. If it's defined means if I encounter a B after B, that means the string is over, and I have to reach the final whole state. So from here I'll just do B, let it stay as B and move to the right. So this is the transition diagram for odd or even palindrome. So here for the language, number of A's and B's are equal. Okay, so what we are going to do is, let's take an example. Let's suppose the string is A, B, B, A. Okay, now see, whenever I encounter an A, I'll make it as X, and then I'll be searching for B. If I encounter a B, I'll make it as Y, and I'll go back and search if any other A is there. If it is not there, then I'll go forward and I'll search for another A. When I search for another A, I'll mark it as X, and I will come back here and I will search there is a B or not. There is a B here, I'll mark it as Y, and then again I will go and search for it. There is nothing there, then I will be stopping it. Okay, so whatever I encounter first, that one I'll be taking as X. Okay, if I encounter A first, A will become X. Suppose if the string was like B A A B. Okay, so here in this case this will become X, and I'll search for the A. This will become Y. I'll come back and I'll search again, and here I'll be searching as B, and B I'll be making as X, and I'll come back here and this will be made as Y. Okay, so in this case we'll be considering the whatever the letter we encounter first as X. Okay, and we'll be searching a corresponding one in the further string, and we'll be proceeding like that. Okay, so let's make the transition diagram. Okay, so first state what we'll start from Q naught. Okay, and Q naught, suppose that I encounter an A first. Okay, if I encounter an A first, what I will do, A is there, I'll replace it with X and move to the right. Same thing goes for B also. If I encounter a B, I'll be replacing it with X and moving to the right. Okay, so we'll consider each one by one. So B comma X is there. Now see, A comma X I replace and move to the right. After I move to the right, I have to ignore n number of A's after that, because I'm in search for the B, right? What I'm in search for? I'm in search for B. So I have to ignore the n number of A's. So I'll be just keeping it as A and moving to the right. After that, whenever I encounter a B, what I have to do is B, if I encounter, I'll mark it as Y, and I'll be moving to the left, right? I'll be moving to the left after I mark the value as Y here. Okay. After that, I've moved to the left, and I'll be coming to the Q2. Now see what happened. A I marked as X, and then after that I got a B, I marked as Y. Then again I'm coming back and searching another A. Okay, like suppose the string was A B. Okay, let's take A B B B. Now see, A I marked as X, I moved forward, I found the B, found, and B I marked as Y. Now I'm coming back and finding A. Now the A which I have to find is this A, the first A. The first A comes after X, not this A. Okay, so how many A's I get in between, that I have to ignore. So I'll be making A L. I'll be moving to the left. No matter how many A's I have, I'll still move to the left until I encounter an X. When I encounter an X, what I have to do is I have to move to the right to start again from here. That means when I encounter an X, I'll be going back here to start from the beginning, like a new string here. Like this A has to be found for its corresponding B. So it will be X comma X and move to the right. Okay, this is for the A. The same thing, just copy paste for the B as well. So yeah, let's make the other one Q3, and here it is AAR. So I'll be making here as BBR. Okay, and number of B's I'm ignoring, and after that I'll be making this state here. It will be um, A comma Y comma L, AYL, and I'll be reaching the state Q4. Here I'll be ignoring the B value here, BBL. After that, when I reach, I'll be making the same transition, which is the XXR. Here also X and R. Now one more thing can happen here. Okay, if we take a mixed string, in that case some other thing will happen. What will happen is, suppose that the string was not A. Let's take the string as A A A B B A B B. Okay, let's take the string as this. So here 1 2 3 4 4 A's and 4 B's. Okay, what happened? X I made it this as X, I came here, I found this, I made it as Y, I came back here and I found this, I made it as X. And when I was going forward from here, okay, after making the first A as X and moving forward, I encounter an A. Okay, after making the A as X and moving forward, I encounter n number of A's which I'll be ignoring. Also, after ignoring A's, I also found Y here, right? Because in the second iteration, I'll also encounter Y's, right? So Y's also have to ignore Y, R. Okay, this is one thing. After ignoring Y's, when I encounter B, then I will be proceeding as follows. Okay, and after that also, when I encounter this as Y here, I'll be ignoring this one and moving to the left. When I move to the left from here, okay, B I made as Y and move to the left. B I made as Y and move to the left. I'm in this state. In this state, when I move to the left, I again found another Y here. So this Y needs to be staying the same and move to the left again. So I'll be in this state. This YYL has to be done here, and I'll move again here. And when I move back from here again, AL X will come. X, when X will come, XXR I'll take from here. So these two things, YYR from Q1. So here with BBR, YYR should be there, and with Q2 here, YYL should be there. Here with BBR, YYL also. Okay. So that's all for this diagram. So based on this diagram, all the things which could be happening are covered here, and we'll be proceeding with this diagram. Okay. So let's move on. Before that, one thing can happen here. Suppose that the string is A, B, B, A. Okay. Now, A I encountered, I made it as X and moved to the right. Okay. And after that, I encountered a B. So I made it as Y and moved to the left. Okay. I move to the left. Now in the left, I have X. When I have X, what I have to do? XXR. Now, after XXR, I move to the right. I have found a Y here. And I'm in this state. In this state, Y is not defined. Right? So if I encounter a Y after X, that means there is no more things present before it, right? It is the end. X and Y, there is nothing in between. So I have to move forward. So what I'll do, I'll ignore the Y's and move forward. Okay, that's all. If Y's are there, I'll move forward. Okay, this applies same for the, have the kind of string where it will be B A A B. Okay, here when I encounter a B, I'll make it as X, and when I encounter Y, A, I'll make it as Y and come back here. XXR, again I'll come back here. Y will be there. Y it will ignore and move from here. AXR it will continue. Okay. So at the end when I reach here, it will be a B. So B also we have to define. So when it is a B, I'll be moving to the final state, which is B comma B comma R. That will be the final state here, and this one I'll make it as Q5. Okay. So this is the hold state. Okay. How does multiplication work is we'll be having m number of zeros and n number of zeros, and the multiplication's answer should be m into n. Okay, let's take an example, 3 and 2. Okay, 3 zeros and 2 zeros here, and after that we'll have another one here, and we'll be having a number of b's. We are going, my answer will be present. Where will my answer be present? My answer will be present after this one, my answer. Okay, and how will be my answer denoted as? When we multiply 3 into 2, we'll get 6, right? So here instead of 6 b's, I'll be having 6 zeros here. Okay, that will be my final answer. So we have to do that conversion of the b's to zeros, and rest all of the things will become b's. Okay, this will all become b. This whole thing will become b, and whatever are there after this one, that will be my answer. Okay, at the end only 6 zeros will remain, and rest all things will become 0. Okay, so how do we do that? So to do that, let me give you an overview. We'll start from here, make it as b. After we made this as b, we'll come here and take these two zeros and put it here. Okay, these two zeros will take and put it here. Okay, after we have done that, we'll come back here and take this 0. I'll cut this 0, and since we encounter another 0 here, again 2 times I'll make this as 0. I'll come back and make this also as b, and again 2 zeros I have to put it as here. So after that, if I encounter 1 here, that means the string is over. Rest all the things I'll make it as b here, and this will be my final answer. Okay, so let's understand using the transition diagram, how does this happen. 0 0 0 1, and here we'll be having a number of b's. So let's take 6 b's for now, because the answer will be 6 in this case. We'll be starting from here. Okay, let's take as q0 here. Okay, now in q0 I have a 0 here. So from q0 I'll be making that 0 as b, and I'll be moving forward to q1. and there I'll be finding n number of zeros here. That one I'll be ignoring, 0 comma 0 comma r. After that I find a 1 here. So whenever I find a 1, I have to change the state, 1 comma 1 comma r. I'll be keeping it as such and moving here. And once I find this one here, 0, that will be here. This first 0, I have to know that I've taken this 0 and kept here, right? So for me to know that I have taken this 0, I'll use a symbol. Okay, that symbol will be, I'll be marking this as 2 here. Okay, for my understanding, I'll be marking it as 2. This is B here, and 2 is nothing. You can take 3, 4, anything, just to denote that this 0 is taken, which I have already put here. If I don't do this, I'll be confused which 0 I am taking now, right? So to keep a track of how many zeros I have taken, I'll be marking those zeros which I have taken as 2. So after I have taken as 2, I'll be making 0 comma 2 comma r. Okay, after that I'll be getting n number of zeros here, which I'll be ignoring. In Q3 I'll be ignoring n number of zeros, 0 comma 0 comma r. After that I'll be finding a 1 here. After I find a 1, I'll be changing my state here. Okay, 1 comma 1 and r it will be. And once I find a b after the first 0, after the second one, if I find b here, that I have to make it as 0, right? So whenever I find a b here, I'll be making it as a 0. Okay, so here I'll be making it as 0, b comma 0, and left I'll be moving. Okay, after marking it as 0, I have to move left. When I move left, I'll be coming to this state q5. Okay, now when I move left from here, after I made this as 0, okay, I'll move to the left from here, and I'll be encountering a 1 here. Okay, that 1 I'll be ignoring the 1 here. Okay, 1 comma 1 comma l. Okay, I'll be ignoring the 1 here. After that I'll be encountering a 0 here, that also I'll be ignoring. Okay, because I want to find the first 0. First 0 how I will find means the first 0 after the ones which I've considered. I'll find out when I encounter a 2 here. The next 0 to 2 is the one which I need to find. So if I encounter a 2 here from this state, I have to move forward and take the next 0 here. Okay, so when I take the next 0 here, what again I'll make it as 2, move forward, again make this as 0 and come back. So this same thing I'm repeating here. When I found first 0 here, remember, when I found first 0 here, what I did, I made it as 2 and move forward. Now I'm finding the same thing for the second time here. So I'm repeating the process which I had already done. That was from this state, right? When I found a 0, I made it as 2 and moved to the right. Now from this state, I'm finding encountering a 2. That means I'll come to this state here. I'll keep 2 as such, 2 comma 2 comma r. So 2 will be here only, and move to this state. And from this state again the process will repeat. So when the process will repeat, this will also become 2, and here I will come. Here this will become as 0, and I'll come back here again. When I come back here, and in this state again 2 is there. From this state 2 is there. 2 comma 2 comma r, 2 will remain same and come here. Now I have come here. That means in this state I found 1. From this state I found 1, right? Initially I was finding zeros, now I found 1 here because zeros are over. So when I found 1 here, that means the number has been repeated once. Now when I do this one, I have to convert these two as again back to zeros, so that I can process another 0 and write this 2 another 2 times. Okay, so in this state I am present and I encounter 1, so I have to take it to the other state. 1 will remain 1 only and move to the left. When I move to the left, I found 2 here. So in this state, in Q6, no matter how many 2's I found, I have to reset it back to zeros. So 2 will be replaced with 0 and move to the left. Okay, so this will become as 0 and move to the left. Again this will become 0 and move to the left. And after that I found another 1. When I find another 1, what I am supposed to do, I have to ignore 1. I have to ignore 1 and come back here until I find B. So if I find 1 here, I'll be ignoring it. I'll be keeping it as 1 only and moving. If I find 0 also, I'll be keeping it as such and I'll be moving it. And I have to find B here, so that I get to know which is the next 0 I have to consider, right? So all zeros I'll ignore until I find B. After I find B, I'll come back to the right. After I find B, I'll come back to the right, and from here I'll repeat the same process which I did from the start state. Now this is the start state here. So when I encounter a B, I'll reach to the start state here. I'll keep B as such, B comma B, and I'll move to this state here. Now this will also become a B here, and I'll move here. These two again, 2 will be there, and again 2 zeros will be there. I'll be not marking it, and I will be coming back here. Another 0 will be there. This 0 will also become B here. I'll go back here. and these two zeros will become these two b's will become zeros. I'll come back here, and at this b I'll move forward. When I in this state I'll get a b, I'll move forward in this state. Now I am in the start state, but now the start state is not anymore zeros. The start state after b is 1. So in this case what it indicates is this string has been over. The string of zeros have been over. That means there is no more repetition that is needed. So this 1 will become as b. Okay, from this case, from now on I'll make all the things till the second one as 1. So this one will become as b, and I'll move to this state here, right? And this will become b, and after that I'll find n number of zeros. In this state q7, I'll make all the n number of zeros which I find as b. All the zeros also should become as b here. So this will become b, this will become b. After that I find the second one. Second one I have to transition here and make that second one as also b, and move to the right. So second one I made it as b and move to the right, and which state I reach, that is a halt state. Why? Because after this I need not do anything. This is my final answer. All the rest are b's, these are all zeros. Okay, so this is the halt state. Okay, so this is the transition diagram you need to make for multiplication Turing machine.